Boys and girls, ladies and gentlemen, Mr. Manise here. Welcome to this video, the one you guys have been waiting for. The video for the final exam review packet for the first semester in geometry. This is going to be a pretty long video because we got 50 problems to go through, so I would encourage you guys to get out your graphing calculator and punch these numbers in with me on your calculator when we get to the quadratics, Mr. Spotty stuff to refresh your memory. And I'm going to skip the disclaimer and my Clemson reference because it's going to be a long video, so let's jump right in. Number one, this is chapter 1 stuff. Based on the pattern, what are the next two terms in the sequence? So you're asking yourself, am I adding, subtracting, multiplying, dividing? How am I getting from one number to the next? I'm simply adding 6 here, I'm adding 6 here, adding 6 here. So I add 6 to 25, I get 31. Add 6 to 31, I get 37. Nothing really to talk about there. You guys hopefully won't miss that one. All right, create your own conditional statement and write the converse, inverse, and contrapositive. So I'm going to draw myself an arrow and go all the way down here to the bottom. Give myself some room. And I'm going to create a conditional statement. What does a conditional statement have? Every conditional statement has an if and a then. I'm going to go with if you go on a diet, then I must have the if and the then you will what? You'll lose weight. You guys don't have to worry about that because you're teenagers. When you get to my age, you become 93 years old, you kind of have to start worrying about that kind of stuff. All right, next we have the converse. Converse. All right, converse. What do you do with the converse? Switch the shoes. So we switch these two statements, okay? The back end goes in the front goes in the back. Okay, so I'll switch this around, and this will look like still an if-then statement. So I have if you lose weight, if you lose weight, then what? Then you are on a diet. Okay. Inverse, put in the knots. So everything stays the same. I'm going to put a knot here. I'm going to put a knot here. Basically, you're negating. You're doing the opposite of what it says. So instead of if you go on a diet, I'm going to say if you do not go on a diet, then what? Then you will not. I'm putting in the knots. You will not lose weight. Okay. If you don't go on a diet, then you will not lose weight. Contrapositive, we're going to do both. We're going to switch the shoes, and we're going to put in the knots. All right, so this goes in the front, and then I put a knot here, so that's going to sound like this. If you do not lose weight, then you are not on a diet. Okay, that is the converse, inverse, and contrapositive. All right, more chapter 1 stuff up here. When you have a biconditional, when you have I just gave the answer away. When a conditional and its converse are true, you can combine them as a biconditional. What does a biconditional have? That has the if and only if statement in there. Okay. What is a counterexample to the following statement? Counterexample is something that disproves the statement. So this is a statement that you go, well, wait a minute now, hold on, that's not true. Here's an example of why that's not true. So the statement is if a number is divisible by 3, then it is an odd number. So a counterexample means I need to find a number that is divisible by 3, but that is not an odd number. Okay, so the first one that comes to mind is 6. Okay, 6 is divisible by 3, but it's not odd. 12, 18, basically every other multiple of 3 is going to be even. Okay, so that would be one of infinite amount of counterexamples. Transitive property. Transitive is if A equals B and B equals C, then A has to equal C. Remember the twin brothers analogy that I, the twins analogy that we used? So if we have one person is identical twin to another person, and that identical twin is identical to another, then they must be triplets, right? All three of them have to be the same. So if CD equals EF and EF equals GH, then these two guys have to be equal to each other. These two are twin brothers. These two are twin brothers. So we have triplets. All right, so CD is going to be congruent to GH. Line CD is congruent to GH. Okay. Number 6. Again, and also guys, every single question on the final, and I mean every last one of them, is going to be exactly like the problems in this packet, and going to be exactly like the problems that we have pulled off of previous tests. Now this is all open response, and of course the final is going to be multiple choice. Okay, so if you can do this packet, you will do fine on the exam. I'm pulling for you guys. I know some of you guys really need to make a good grade. I want you to watch this video, do your work, study, come in for tutoring. I want you guys to make that grade that you need on the exam to make the grade that you want in the class. Alright, so this is straight off the chapter 1 test. This is the one that said, okay, these two guys are what? They're across from each other, so we're going to call those vertical angles. Okay, I'll put a little V here for vertical. On my answer key, I write everything out, so don't just watch the video. Y'all can go online to my website, check the solutions where I do a little bit more meticulous, writing out the details of how you do each of these problems. But then, since this is a video, I'm just going to kind of talk through it a little bit quicker. So these two guys are vertical, so they're going to be equal to each other. So I'm going to set 7x plus 7 equal to 112. Let's subtract 7. 7x is equal to 105. Divide both sides by 7, and x is going to be equal to 15. Okay, so that gives us x. It's asking for x and y. Okay, what do we know about these two guys? Okay, those are not vertical. Okay, these are supplementary. They form a linear pair. They form a line. Okay, so both of these guys added together have to equal 180 degrees. So I'm going to say 4y equals 4y plus the 112. When I add them together, they're supplementary. They got to be equal to 180. So let's subtract 112 from both sides, and we get 4y is equal to 68. Divide by 4, and we get y is equal to 17. Okay, proofs, the thing you guys love the most. I know this is your favorite thing. Fortunately for you guys, the test is multiple choice, so you're just going to have to fill in the correct blanks. So this is going to be a little bit harder writing these proofs out by hand. So they're asking us, why are Q and W supplementary? If lines A and B are parallel, so this is all the same side, alternate interior angle stuff, why are Q and W supplementary? And no, unfortunately, you can't just use Mr. Manise's little trick and say, oh, well, Q is big and W is little. So Mr. Manise taught us that it was one big and one little equal 180. That's not going to cut it in the proof, although that is correct. You've got to find a path. How can I get from Q to W? Okay, can I go this? I can go from Q to S and S to U and then U to W. I can do that, but that's a whole bunch of supplementary stuff. Why not take the easier path? Let's hop. We're a frog. Well, let's hop from Q to R. That's one path, and then we're a frog hopping on petals, and the frog's going to jump from R to T. And then the frog is going to jump from T to W. So that's the path. Q to R, R to T, and then T to W. All right, so I'm always going to set up my proof with statements and what? Reasons. This is what lawyers do. That's why you're learning this stuff. All right, logical process and series of steps. Okay, so always going to start with a given. So angle Q, or excuse me, A is parallel to B. That's the given. And then I'm going to start for this path. What do I know about Q and R? I'm going to say that angle Q is congruent to angle R. And why is that? Why is that true? Well, they're vertical angles. We just talked about that in the previous problem. Vertical angles that they form, they're across from each other. They form an X, or they form a V, however you want to think about it. Vertical angles. And then now we're going to hop from R to T. R to T are same side interior angles. If the lines are parallel, same side interior angles have to add up to 180. They're supplementary. So I'm going to say the measure of angle R plus the measure of angle T is equal 180 degrees. Why is that? Same side interior angles. Okay, we're a frog. We're hopping from here to here, from here to here. Now we're going to hop from T to W, which is eventually what I want to get to. What do I know about T and W? Same thing as the second step. Angle T is congruent to angle W because they're vertical angles. Okay. All right, so now the hard part, the $50,000 question, how does that help me with Q and W being supplementary? Why are Q and W adding up to 180? Well, if Q and R are the exact same thing, and T and W are the exact same thing, then instead of an R, I'm just going to replace the R with a Q because these two guys are the same. So instead of an R right here, I'm going to put a Q right there. And since T and W are the same, instead of a T right there, I'm going to substitute a W right there. So I'm substituting a Q there, and I'm substituting a W there. So now I can say the measure of angle Q plus the measure of angle W is equal to 180 degrees simply by substitution. Substitution. Okay, so let that sink in. Rewind the video here if you're still not grasping that. Just take it slow. Keep watching that over and over to make sure you have a good handle on that. Okay, page 2. Page 2. All right, so we have all the chapter 2 stuff. Okay, so it's saying list a pair of angles for each. Alternate interior angles. Alternate. I'm zigzagging back and forth across the transversal. They're on opposite sides of the transversal. Interior, it's got to be inside my sandwich, right? The meat of my sandwich. All right. So alternate interior would be 4 and 5. Angles 4 and angles 5. And 3 and 6. Those are alternate interior. Okay, same side. That means on the same side of the transversal, and they're still inside the sandwich. So that would be like 3 and 5. I mean, I'll do a box. 3 and 5. They're same side interior, and then 4 and 6 are same side interior. Alternate exterior. Okay, so I'm alternating across opposite sides of the transversal. Now I'm outside the sandwich. I'm exterior. Do a triangle. So there'll be 1 and 8. And 7 and 2 are outside the sandwich and opposite sides of the transversal. All right, and then a hard one, corresponding. Okay, this is one where you got to use my little trick that I taught you. Just look, draw yourself a little box around the clusters of 4 angles, and corresponding would be in the same spot in the window and same spot in the box. 1 is in the top left, so 5 is in the top left. So angle 1, angle 5. 3 is in the bottom left, 7 is in the bottom left. Angle 3, angle 7. 2 is in the top right, 6 is in the top right. Angle 2 and angle 6. 4 and 8 are both in the bottom right, so they are corresponding. Okay, number 9. The expressions in the figure below represent the measure of 2 angles. Find the value of x. F and G are parallel. Okay, so once again, if the lines are parallel, same side, corresponding, all that stuff comes into play. But here's where you can use my little trick. What I taught you was when the lines are parallel and you're looking at one transversal, if I want to extend this out, all of the big angles are the same, all of the little angles are the same. 1 big plus 1 little equals 180. 3x, when I say big and little, that just means big is greater than 90 degrees, little is less than 90 degrees, or obtuse or acute, if you want to think about it that way. 3x is big, 8x plus 37 is little. Okay, so when I have one big and one little, they're supplementary. They're going to add up to 180. So 3x plus 8x plus 37, those have to equal 180. Okay. The other way to think about it, just use common sense. Okay, 1 big plus 1 little is 180. If they're both big, they're the same. If they're both little, the same. But these angles, are these the same? No, these two angles are not the same, so that should be kind of a red flag. Wait a minute, this is probably 2 angles are supplementary. These are same side interior angles, by the way, and we know that same side interior angles postulate says they're supplementary. So I'm going to combine my like terms. 11x plus 37 equals 180. Subtract 37. 11x equals 180 minus 37 is 143. Divide by 11. And we get x is equal to 13. Okay, guess what? We get to do it again, the big little trick. Find the value of x. Okay, as big, dash big. They both big. Okay, so if they're both big with parallel lines, here's my transversal. These are actually alternate interior angles, so I'm going to simply set them equal to each other. Let's add 32. 3x equals 132. Let's divide by 3. and x equals 44. Okay. Always go back, guys. For sake of time, since this is going to be a long video, always go back and plug your answers back in. I'll just do that here real quick. 3 times, we're saying that x is 44. 3 times 44 minus 32, that better equal 100. Ta-da, it does. So please, please don't turn your final exam in to the box until you've gone back and checked every single one of these that you can check. You can do the same thing up here. Plug in the 13, plug in the 13, make sure that equal 180. Okay. That's why I love math. Just check your answers. You know most of the time whether or not you're right or wrong, especially with algebra. Okay, making good time. On to page 3. Page 3. You recognize that problem? Yep, that's right off the chapter 1 stuff. Okay, so let me get my answer key set up here. All right, what do you know about angles? We're trying to find x. Now, if I knew the other two angles, then I could find x by just saying, I just take 180 and I subtract the two angles. That always gives me the third angle using the triangle angle sum theorem. But I don't have two angles. I need this angle, so that tells me, I better use that number. If that's 110, then this is 110. Why? Because they're vertical angles. Vertical. And so now I have, anytime you have two angles of a triangle, I've got the 110, I've got the 48, I just subtract that from 180. 180 minus 110 minus 48, and that gives me 22 degrees for my missing angle. Okay, check it. 22 plus 110 plus 48, make sure that equals 180. Okay, number 12, it says in the diagram above, if the measure of angle 3 is 115, so I'm just going to scratch this out, I'm going to write in a 115, what is the measure of angle 8? Okay, well, 115, is that big or little? Well, I know it's big because the numeric value is greater than 90, so that's big. Okay, 8, is that big or little? That's little. So they're supplementary. So 115, I'll just say plus x is equal to 180. Subtract 115 from both sides, and x is equal to 70, or excuse me, x is equal to 65 degrees. Okay, all of the big ones are the same. So 2 is big, that's 115. 6 is big, that's 115. 7 is big, that's 115. 1 is little, 65. 4 is little, 65. 5 is little, 65. 8 is little, 65. If you tell me with two parallel lines, if you give me one of the angles, I can tell you the other 7 almost immediately. Okay, y'all remember this one, the star props? This is also off of chapter 2 test. All right, so this says a pattern quilt has a star with the angle shown. What is the value of x? Okay, now there are two ways to do this. One way, the hard way or the long way, is to say, well, I'm going to use the 3 angles of a triangle. If this is 110, these two angles are supplementary, so 180 minus 110, that gives me this guy, which is 70. And now I have 2 angles of a triangle. I can just do 180 minus the 36 minus the 70, and that gives me 74 degrees. Okay, that's one way to do it. The other way to do it, if you guys know the theorem, is to say this is my exterior angle, and these are my 2 remote interior angles. Remember, remote control, we're operating the remote control on the opposite side of the wall where the TV is. And our exterior angle theorem says that the sum of the 2 remote interior angles has to equal the exterior angle. So I can just simply say 110 is equal to 36 plus x. Subtract 36, and I get x is equal to 74. It just saves you a step. I don't need that angle if you remember the remote interior exterior angle theorem. All right. Given that triangle QRS is congruent to triangle TUV, what is that called when I say one thing is congruent to another thing? That's a congruent statement. QS is 4V plus 3, TV is 5V minus 6. Find the lengths of QS and TV. Doesn't ask for V, it asks for the lengths of QS and TV. I'm going to come down here and give myself a little bit of room. All you got to do, guys, is look at your congruent statement. QRS is congruent to TUV. Okay, QS, the first and third position. TV, first and third position. So that means those two lines have to equal each other. So I'm just going to set these two expressions equal to each other and solve. 4V plus 3 is equal to 5V minus 6. Let's leave ourselves a positive variable, so I'll subtract 4V from both sides. 3 equals V minus 6. Add 6 to both sides. and V equals 9. Now you know, guys, on the final exam 9 is going to be one of the answers. Okay, so you got to pay attention and make sure you read the directions, what the problem is asking for. They want the lengths of QS and QT. I'm going to take this 9 and plug it back in where? This one or this one? The answer is it doesn't matter because these two guys are equal to each other. I'm going to plug it back into this one because I'd rather do addition than subtraction. So I'm just going to plug it in right there. So I'm going to say 4 times 9 plus 3, and that is simply equal to 39. Okay, let me plug it into both just to check. I'm real big on checking. 5 times 9 is 45 minus 6. Guess what? That's also 39. Okay, so I feel good I've done the problem correctly. Number 15, I'll do over here. Number 15 is the same thing, but except now we're trying to find the angles. Triangle ABC is congruent to triangle PQR. That's also a congruent statement. B is 2V plus 3, and Q is 5V minus 9. Well, where is B? B is in the second slot, and Q is in the second slot. So I know they're both congruent. They're both equal to each other. So I'm going to say 2V plus 3 is equal to 5V minus 9. Let's leave ourselves a positive variable. So I want to subtract 2V. 3 equals 3V minus 9. Let's add 9 to both sides. I'm pretty sure that's 12, but I'm no math teacher. Divide by 3. V equals 4. That's all well and good, but I got to take this guy and plug him back in. I'm going to plug it back into the easier one. Alright, so 2 times V, which I don't know why I wrote V. 2 times V, which is 4, plus 3, that's 8 plus 3, that's equal to 11. Plug it into the other one. V is 4. 5 times 4 is 20, minus 9, that's also 11. Okay, so that would be the measure of angle B and the measure of angle Q. And the 39 would be the QS and the TV lengths. Okay. Alright, so that's how you do those problems. Okay. Turning over to the next page, page number 4. Oh my goodness gracious. Goodness gracious. 2 proofs. What are you trying to do to us, Mr. Manice? What are you doing? I'm just trying to get you guys ready in case you decide you want to go into law, where you have to present your case in front of the judge and you have to provide statements and reasons. You have to take the evidence that's provided to you and present your case to a judge or a jury. Or in my case, I was a chemical engineer. I've got to present my procedures and my ideas to the plant manager, to the engineering manager, and say, here's why we want to do this. Because of this, that it means this. Because of this, that means this. That's why you're learning proofs. Okay. I'll shut up now. All right, write a 2-column proof. So in my proof, I've got to have my statements and my reasons. Statements. That's the evidence. Your Honor, he is the suspect. He is guilty because of my reasons. All right, so I always want to start off with a given. I'm going to say AB is congruent to DC given AC is congruent to DB given. Now, here's the part, guys, when these proofs with triangles and angles, you've got to ask yourself the question, where can I add arcs and ticks to my diagram? Where can I add stuff? They've told me that AB is congruent to DC, so that's not really adding any ticks because that's part of the given. AC is congruent to DB, so I'm going to double ticks, double ticks. That's just given information. That's the evidence. What else can I do to my diagram? Always, always, guys, ticks in the middle. Okay, so I'm going to say that BC, and when I add a tick or arc to my diagram, I got to explain why that is. BC, I put a tick on itself, so BC is congruent to itself because of RPC, reflexive property of congruence. Ticks in the middle is always reflexive property of congruence. Now, do I have enough information to prove my client innocent, guilty, whatever? Yes, I do. Now, I'm just going to bring this down here. I've been asked to prove that triangle ABC is congruent to triangle DCB, and the reason for that is because I've got tick, ticks, ticks, side, side, side. 3 sets of ticks, side, side, side. That's pretty easy. Number 17, write a 2-column proof. Statements, reasons, presenting our case. The given is angle M is congruent to angle P, and MO is congruent to PO given. All right, now let's go ahead and make our arcs for what they've given us. Angle M, now angles is going to be arcs. Angle M is congruent to angle P. And then MO, that line segment, that guy is congruent to PO. Okay. So now I've got to ask the question, where can I add arcs and ticks to my diagram? Remember with these triangle congruence postulates, SSS, SAS, all that stuff, I need three things. I need three sets, some combination of arcs and ticks. All right, so I can always add arcs at vertical angles. So if you got that, good job. So now I need to say, I'm going to say that angle, M-O-N, M-O-N, and I got to use the three-letter method here, guys. I can't say angle O, because I don't know what you're talking about. There's 4 different angles with angle O. I got to say M-O-N. That angle is congruent to angle P-O-Q. P-O-Q, okay? And the reason for that is because vertical angles. They are across from each other. Okay, now, am I ready to prove that line NO is congruent to QO? Because what we're trying to do with these triangles is using one of our postulates, SAS, ASA, whatever, to prove the triangles are congruent. So that's what I need to do first before I get to this part. So I need to say that triangle, I'm going to say triangle MON is congruent to triangle POQ. And the reason for that is angle, side, angle, angle, side, angle. Hopefully you guys are good at this by now. I'm not going to go into too much more detail about that. I've got videos on my website if you're still not sure about the SAS stuff. Alright, so they're congruent by ASA, but notice that's not what they want us to prove. They want us to go one step further and say, okay, why is it that NO, why is this guy congruent to QO? Why am I able to put ticks there? And this is the analogy that I use. If you guys are watching this video for the first time and you never had me as a teacher, I use an analogy of twins, right? Twin sisters. If you tell me, if I got 2 girls that walk up to me and they say, Mr. Manise, we're twin sisters, I can say, oh, okay, that tells me a lot. That tells me you got the same, probably got the same hair, probably got the same foot size, your facial features are the same, a lot of stuff about you is the same. It's the same thing with triangles. Once you come up to me and tell me these 2 triangles are twin sisters, I can say, oh, well, everything else about them is the same. That means these 2 lines have to be the same. These 2 angles have to be the same. These 2 lines, NO and OQ, have to be the same. So now I'm able to say NO is congruent to QO because they're twins. Okay, I can't write twins. How do we say twins? We say CPCTC. Corresponding parts of congruent twins are congruent. That's not twins, that's triangles. Corresponding parts of congruent triangles are congruent, but I use the same analogy with twins. Okay, hopefully that makes sense to you. So just remember, with these triangles, if they ask you to prove something other than just proving the triangles are congruent, then up here we're done. We stop with the SAS or whatever. If they ask us to go one step further, it's always going to be CPCTC. Okay, number 18. What common side do triangle CDE and FED share? I'm going to color code these. I would strongly suggest that you guys separate these out. Triangle CDE, I'll do in green. Triangle FED, I'll do in red. FED is in red. So hopefully you can obviously see where do I have green and red overlapping, and that's this guy right here. So DE is the line that's being shared, okay, with the overlapping triangle stuff. Color code it, separate out the triangles. This one's pretty easy, so you don't really need to separate out the triangles. So this one, you can just kind of look at, but I color coded it anyway. But if it's a little bit more complex, you need to separate them out, color code them, so your brain can see, okay, this angle is being shared between both triangles, or this line segment is being shared between both. Okay, page number 5. Page number 5. Okay, still in geometry land here. All right. Find the values of A and B. Okay, what do these arrows mean? Parallel lines. So you can use my trick here, but the difference is this time I can't say all the big angles are the same and all the little angles are the same. Here are my 2 transversals. I can't do that because I have two different transversals. I got one transversal that's angled this way, and I got another transversal that's angled this way. My little trick works if you have two lines that are parallel with just one transversal, or if you have another transversal and these two lines are also parallel. Then you can say all the big ones are the same, all the little ones are the same. But here, it's almost like you got to kind of turn a blind eye to one of the transversals. Let's just treat this like a normal problem from chapter 2. Okay, I can say all the big ones are the same, all the little ones are the same. A, what's that? Big or little? That's big. 62, I know that's little because it's less than 90. 62 is less than 90. So when one's big and one's little, they have to add up to 180. So I'll do A plus 62. They're supplementary. Now these are same side interior angles, and we know same side interior angles are supplementary. Subtract 2 from 62 from both sides, and we get A is equal to 118 degrees. Okay. Now for B, this is a common mistake. Students will say, oh, 62 is little, B is little, so B has to be 62. No, that's because this transversal is different. It's a different transversal than this. So once again, you kind of have to turn a blind eye to the left side and treat this like it's its own transversal problem. Once again, 105 is big, B is little. These are same side interior, so these are also supplementary. B plus 105 equals 180. Subtract 105 from both sides, and B is equal to 75 degrees. Okay. Oops, sorry, can't see that. B is 75. Oh boy, here we go. We are leaving the land of geometry temporarily. We're going all the way back in our time machine, back to polynomials and quadratics. Okay, so this is where we have our best friend, Mr. Graphing Calculator. We can check all of this stuff. All of the stuff. All of it. We can check with our calculator. You got a winning lottery ticket in your pocket. This says combine like terms and name the polynomial based on its degree and number of terms. Notice there's no equal sign here because there's no equation. No equal sign, no equal sign, no equal sign, no equal sign, no equal sign. We're just simplifying the expression, okay? So in order to combine like terms, you got to have two things, two rules that are satisfied. Number one, they have to have the same base or the same variable. So I do the little analogy of apples and oranges, fruit, apples, oranges, bananas. Okay, the second thing is the exponents have to be the same. So I've got an x squared here. I'll do this in different colors. I've got a 14x squared here. Let me maybe zoom in a little bit for the algebra stuff. Okay, we've got a 14x squared here. I've got a negative x squared here. So those are my apples. I have 14 apples minus 1 apple. I have 13 apples. I have 13 x squareds. Do I have any x's? No. I have negative 7 and 11, so you just combine your constants there. 7 minus 11 is plus 4. Okay, so my final expression is 13x plus 4. Then it says, based on its degree and number, name it based on its degree and number of terms. Okay, so the highest exponent tells me the degree, and the highest exponent is 2. So that's a quadratic. Okay. If the highest exponent is a 1, that's linear. That forms a line. Highest exponent is a 2, that's quadratic. If it's a 3, it's a cubic. Anything after that, we just say the number. 4th degree, 5th degree, 37th degree, whatever. Okay, it's a binomial because I have 2 terms. Monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. And then after that, we just say polynomial. Okay, so this is a quadratic binomial. Quadratic because of the 2. Binomial because of 2 different terms. And remember, terms are separated by pluses and minuses. Got 2 terms. We have our trusty calculator, guys. Trusty calculator. Let's check it. All you have to do is type in the original problem, get a number, type in your answer, get a number, and make sure they match. So if you guys still have the numbers programmed to your letters, if you guys have a different teacher, you've never had me as a teacher, then you might not be familiar with this trick. If you've never heard this trick before, you can go to my website, go to videos, go to other videos, and I've got a video that will walk you through how to program assign numbers to every letter in your calculator so that you can do this little trick that I'm about to show you. We're using x's here, so I'm just going to type in my expression. Negative 7 plus 14x squared plus 11 minus x squared. I do not care what this number is, and you can use this trick next year in advanced algebra as well. I just want a number, 17, whatever, don't care what the number is. Let's type in our simplified answer, 13x squared plus 4. That better equal 17, guys. That's a winning lottery ticket in your pocket. Anytime you simplify algebra, you can use this little trick. It's a wonderful tool. Okay, so don't forget that. All right, simplify. There's no equation. Simplify the difference. So I've got a minus sign in between both of these guys. When I have a plus here, I don't even need the parentheses. I just combine my apples and oranges and go from there. But when there's a minus sign, guys, you've got to distribute the negative. That means you're going to flip all three of these signs. So that's going to become a plus, that becomes a minus, that becomes a plus. So I'm going to rewrite this expression. Negative 3x squared minus 10x plus 6x to the fourth. I don't need parentheses anymore. That's going to become a positive 9x to the fourth. That's going to become a negative 5x squared, and that's going to become a plus x. Now it's time for apples and oranges. Let's go red for apples. Okay, my highest degrees are the 4. So I've got 6x to the fourth, and I've got 9x to the 4. So I have 9 apples. I have 6 apples plus 9 apples. How many apples do I have? I have 15 apples. So 15x to the fourth. Okay, let's go limes. I'll use green for limes. I've got negative 3 limes, negative 5 limes. Remember, the bases and the exponents have to match. Negative 3 limes and minus 5 limes is negative 8 limes. Okay, let's go blueberries. Blue for blueberries. I have negative 10 blueberries and 1 blueberry. Negative 10 plus 1 is negative 9 blueberries. Okay, they still want us to, we want to write this in standard form. Okay, so remember, when you write it in standard form, the highest exponent has to go first, decreasing from left to right. So I go 4, don't have any 3s, I go 2, and then I go to 1. I don't have any constants. Okay, they say write it in standard form. In standard form. If I wanted to name this, what would this be named? The highest degree is a 4, so I would say this is a 4th degree, and I have 1, 2, 3 terms. This will be a 4th degree trinomial. Okay, I'll write that down anyway, even though they don't ask us for that. Okay, number 22, GCF. What does that stand for? Greatest common factor. Okay, greatest common factor. How do I find the GCF? Two things. I want to find the highest number. Don't even look at the x's. Okay, just look at the numbers. Just look at the 36 and the 24 and the 8. I want the highest number that divides evenly into all three of these terms. Now, the trick that I taught my students was start with the lowest number and see if that goes into all three of them. Because if the lowest number goes into every other term, then that is your GCF. Does 8 go into 24? Yep. Does 8 go into 36? No, it doesn't. So now let's take our smallest number and let's drop it down to its next lowest factor, which would be a 4. Does 4 go into 8? Does 4 go into 24? Does 4 go into 36? So the highest number that goes into all three terms is a 4. And now, to get the variable, you got to choose the variable with the smallest exponent, the lowest exponent. The lowest exponent that I have is a 2. So my GCF is going to be a 4x squared. Think about it this way. I want to take away the greatest, I want to take away the most number of x's from all three of them. This guy is holding up 2 x's, this guy is holding up 3 x's, this guy is holding up 7 x's. I can take 3 from 7, I can take 3 from 3, but I can't take 3 from 2. This guy only has 2 x's, so I can only take 2 x's from him. That's why it's always the variable with the lowest exponent. Okay, in 23, FOIL, 3 different ways to do this. Or 3 different ways to distribute 2 binomials. You can do the distributive property, you can do the box method. I think FOIL is the easiest. FOIL stands for first, outer, inner, last. So I'm going to multiply the 2 first terms. 4x times 2x. Now don't forget, guys, when you're multiplying exponents, you add the exponents. Up here, we didn't do anything with the exponents because all I'm doing is combining like terms. I'm just adding apples and oranges. So when I add negative 3x squared minus 5x squared, that's still negative 8x squared. I don't do anything with the exponent. That's only when you add. That's when the product rule, the power rule, all that stuff from the exponents unit comes into play. Let's say, so 4x times 2x is 8x, and I've got to add the exponents. That's an understood 1 and an understood 1. So I got to add the 1 plus the 1. That is 8x squared. Okay. O stands for outer, so I'm going to multiply the 2 outside terms. 4x times 7 is just 28x. Okay, and then I for enter, I'm going to multiply the two inside terms. So negative 3 times a positive 2x is just negative 6x. And then L for last, multiply the two last terms. Negative 3 times 7 is negative 21. Okay, but we're not simplified yet until I've added all of my apples and oranges in combined like terms. I've got an 8x squared. I don't have any other apples. So I still just have 8 apples. I've got 28 oranges minus 6 oranges. So I have 22 oranges. And I can't do anything else with the negative 21. Okay, so that's my simplified answer. Okay, can I check that? Let's type in the original problem exactly the way you see it. 4x minus 3, parentheses, 2x plus 7, get a number. Don't care what that number is. 9, cool. Let's type in our simplified answer. Remember, when you simplify something, you're just saying that this guy equals that guy. It's just a different form. It's a different way to say the same thing, so they're equal to each other. So when I type in 8x squared plus 22x minus 2, I better get Oh, 21, 20. See, look what happened. I made a mistake in my final answer, and I caught the mistake. I would love to tell you that I did that on purpose, guys, but I didn't. Teachers make mistakes too. See, that's beautiful. I caught my own mistake. Let's go back and type in the answer. 8x squared plus 20. You guys are probably yelling at the video, weren't you? I know, you're yelling at me. You're making fun of me. That's fine. Anything for a laugh. Minus 21. That better equal 9. And it does. Whew. I love it. Beautiful. That's a good teaching point right there. All right. What is the factor form of each of the following expressions? Do you see an equal sign here? No, you don't. We're not solving anything here. I'm simplifying. I'm going from one form to another form. All right, here we go. Factoring. Is there a number in front of that? No, there's not. Okay. So when I'm factoring, it's either factoring when a equals 1 or factoring when a is not 1. In this case, we're factoring when a equals 1. So all you got to do is look at this guy right there. Look at the c term and say, what are the factors of c that add to the b term? So I'm thinking to myself, what times what equals 90, and at the same time, what plus what adds to negative 19. Now, if you're not good at doing these factors in your head, Mr. Calculator is here for the rescue. I'm simply going to press the y equals button right here, y equals, clear that out, maybe clear, and I'm simply going to type in my number divided by x. I want factors from 90, so I'm going to go 90 divided by x, and then I'm going to press second table, and here is all of your lists of the factors for 90. 1 and 90, 2 and 45, 3 and 30, 4 and 22.5. We don't pay attention to the decimals. We're only looking at the whole numbers. Okay, so I'm simply going to scroll down through here and see if I see a combination of numbers that will somehow get me to a 19 or a negative 19. 3 and 30, that doesn't do it. 5 and 18, that doesn't do it. 6 and 15, that doesn't do it. So let's keep going. 9 and, there we go. 9 and 10, that will get me to a 19. Okay, so there are the two numbers. Now the question is, which one is positive and which one is negative? My C term is positive, which means either both factors have to be positive or both factors have to be negative, but my B term, the middle term, is negative. So the only way to multiply two numbers and get a positive and add them together and get a negative is if they're both negative. So my two factors are negative 10 and negative 9. Okay, and so now there's no equal sign here. I didn't do the rainbow, I didn't do the curtain, I didn't do any of that stuff. I just need to get these two numbers, and that's the numbers that go in my two sets of parentheses for my two binomials. It's literally going to factor as d minus 10 and d minus 9. That's it. Negative 10 times negative 9 is 90. Negative 10 plus negative 9 is negative 19. So it's just, we're using d's here. So d minus 10, d minus 9. That's it. Students love to make that more complicated than it is. And notice I'm not flipping any signs here. Remember we say flippy flip? There's no equal sign here, guys. There's no equal sign. I'm not solving anything. I'm not setting this equal to 0, none of that stuff. I'm just simplifying my answer. Okay, so make sure you're comfortable with that important concept. Okay, number 25, x minus 9. Well, I don't even have three terms. I can't factor when a is 1. I can't factor when a is not 1. So if you remember the chart on my wall, number 2 says special cases. Okay, and this is a difference of squares. When you only see two terms with a minus sign in the middle, that's a difference, minus for difference, squares. X squared is a square. I can take the square root of x squared. 9 is a square. I can take the square root of 9. The square root of x squared is just x, and the square root of 9 is just 3. So if you remember our rules, when you factor a difference of squares, one of your binomials will be negative and one of your binomials will be positive. It doesn't matter which order you put them in. Can I check that? I'm not going to check every single one, guys, but I just want you to get into the habit of doing this because it's such a cool trick. X squared minus 9, get a number. Okay, fine. And we think that is equivalent to x plus 3, x minus 3. Is it? Yay. Go on to the next problem. Confetti falls from the sky, and you're guaranteed to get that problem right. Number 6, a little bit trickier, guys, a little bit trickier. So, are there any factors of 1 that add to 5? No, okay. All right, so I can't factor when a is 1. So this is factor when a is not 1. This is where you got to do the rainbow thing, okay? Rainbow. You got to multiply the first number times the third number. I got to multiply a times c. This is my a, my b, my c. 6 times 1 is 6, okay? So I've got to figure out what are factors of 6. What are factors of, when I multiply a times c, I get 6 times 1 is just 6. This is my temporary number, okay? This number doesn't necessarily show up anywhere else in the problem. I just need factors of this temporary number in the cloud that will add to the middle number, okay? So what are factors of 6 that add to 5? And that's simply going to be 2 and 3, okay? So now I'm going to take this middle term. When you do the rainbow and factor when a is not 1, I'm going to take this middle term and I'm going to split it. I can take $5 and I can split that into $2 and $3, and I haven't changed anything. So this is where I'm going to draw my curtain. I'm going to split, draw the curtain. I am going to split my expression into from 3 terms into 4 terms. So I'm going to have 6x squared. Now it doesn't matter where you put the 2x on the left or the 3x on the left. I will match up the 2 with the 6 because they're both even. So I'm going to split that into 2x and 3x, and then I have the plus 1. So let me stop there. Let me refresh. What in the world did I just do? 6x squared plus 5x plus 1. I still have the 6x squared and the 1. All I've done is I've taken 5x's and I've split that into 2x and 3x. Because 2x plus 3x is 5x. Now, why did I do that? The reason I did that is because now I can factor by grouping. This is the curtain, okay, or the line or the wall, however your teacher taught you. Draw your curtain, and now I've got to pull out the GCF from the 2 terms on the left and the GCF from the 2 terms on the right. What's the highest number that goes into 6 and 2? 2. The variable, the lowest exponent, is x. Okay, now when I pull out the GCF, when I'm trying to figure out what's left over, you've got to go back to each term and divide it by the GCF. Okay, so 6x squared divided by 2x is 3x. 2x over 2x, they just cancel. And no, that is not 0. Anything over itself is just 1. Okay, they don't just disappear and go away. Okay, what can I pull out of this? Jack diddly squat. So all I can pull out is a 1. Guess what? That's going to leave me with 3x plus 1. Notice, guys, that these binomials match. If they don't match, do not pass go, do not collect $200 because you did something wrong pulling out the GCF. They must match. And also remember, guys, if there's a negative in front there, only in the front term, I don't care about the second term. In the front term, you've got to factor out that negative with the GCF or these guys won't match. Okay. Thankfully, they were nice to us on this one. Okay, so now where do we go from here? These are my 2 factors. The matching binomial in the parentheses, that's one of my factors, 3x plus 1. And then the other stuff on the outside left over, that's my other factor, 2x plus 1, the stuff left over on the outside. And again, I'm not solving anything. There's no equal sign here. I don't flippy flip. I don't set anything equal to 0. That's it. That's my final answer. Watch how fast it takes me to do this. 6x squared plus 5x plus 1. Get a number. Let's type in our answer. 3x plus 1, 2x plus 1, 12. They match. I don't understand why students won't take 10 seconds and plug this into the calculator and use that little trick that I've taught you to guarantee yourself you've done this correctly. Okay. Okay, so it says suppose the area of the lawn is 9x squared minus 12x plus 4. What is the length of one side? I have a square here, and the area is 9x squared minus 12x plus 4. Okay, so what is the length of one side? I got to factor this. Now this, when you see these lawn, square, area problems, you know it's going to be a special case. Now this is not a difference of squares because I only have two terms. This is a perfect square trinomial. That means I can take the square root of the first term. Square root of 9x squared is 3x. I can take the square root of the back term. The square root of 4 is 2. Now when I multiply, you got to remember the rules. When I multiply these together, 3x times 2, that's 6x. When I double that, do I get the 12x? I don't care about the sign for now. Yes, I do get 12x, okay? So it's simply going to factor as the square root of the first term there, the square root of the second term. I'm going to put a parentheses squared around it, and then what do I do with the sign? I just bring down the sign. If that were a plus 12x, then this would be a plus 2. But it's a minus, so I bring down the minus. But it's only asking for one side. That means my garden, or my lawn in this case, is 3x minus 2 by 3x minus 2, because on a multiply length times width, I get my 9x squared plus 12x plus 4 term. Okay, so one side is only going to be that guy. So the 3x minus 2 is just one side of my lawn. Okay. All right, solve the following quadratic using the square root method. Okay, this is method number 3 on the wall. All you got to do in the square root method is isolate the squared variable. I got to get that guy by himself, and I will take the square root of both sides. So how do I get y squared by itself? Treat this just like it were a y. What if this is just a 3y? What would you do? Okay, I would subtract 10 from both sides, and I would have 3y is equal to 27, but we don't have y. We have a y squared. I still got to get this guy by himself. I can't have any coefficient attached to it, so I got to get rid of that guy. So I need to divide by 3. Y squared equals 9, and square root method. I'm going to take the square root of both sides. The square root of 9 is 3. Did you hear that sign? I literally got out of my desk to go over and ring the bell. Why did I ring the bell? It is not 3. I would play the song here if I didn't have such a long video. Don't you forget about me. Remember I played that song on the piano? Don't you forget about me. Okay, plus or minus 3, guys. Do not forget the plus. You know y equals 3 is going to be one of the answers on the final. Don't fall into that trap. Plus or minus 3. Can't forget the negative. Don't you forget about me. Okay. All right, 29. Solve the following quadratic. Okay, solve. Okay, notice solve, equal sign. Okay, so after we factor this stuff, I'm going to have to go back and flip the signs. Okay, so in the first one, we are solving by factoring. We're solving when a equals 1. Come on back, camera. You can do it. Focus. Clock is just ticking away. Sometimes my webcam does this where it takes a few seconds to auto adjust. I hate to go through all this stuff while it's still fuzzy. Okay, you guys might just have to bear with. There we go. Thank you, webcam. Welcome back. Good to see you. All right, so I need to solve this by factoring. This is a equals 1. What are the factors of negative 18 that add to negative 3? What times what equals negative 18? What plus what equals negative 3? Okay, so once again, if you're not good at this, you can type it into your calculator. Hopefully you guys, these are smaller numbers. You should be able to do this. The two numbers that multiply to give you 18, 1 and 18, no, that doesn't work. 2 and 9, no, that doesn't work. 3 and 6, okay. So the question is, I've got 6 and 3. The question is, when this back term, when the C term is negative, that means the only way to multiply two numbers and get a negative is if one is positive and one is negative. All right, so how do I, either the 6 is positive or the 6 is negative. How do I figure out which one is which? Look at the sign of the middle term, and that tells you the sign of the bigger number. So the middle term is negative, the bigger one has to be negative. Okay, so I got negative 6 and 3. So we said a few problems ago, it just factors as, oh, not X, we're actually using A's here. Okay, so it factors as A minus 6 and a plus 3. It's just simply those two numbers, negative 6 and 3. That's what goes in your binomials. Okay, but now we've got an equal sign. We're actually solving these guys. Now remember, if there's no coefficient in front of your variables, all I have to do is flippy flip. Okay, just flip the signs. A equals 6 and a equals negative 3. Okay. Now, if you want to check this with your calculator, you can do this one of two ways. You could just plug in these two binomials and make sure it matches that number. But if you want to actually plug in your actual answers to make sure you didn't mess up the flippy flip, then you just need to take each of these numbers and actually plug it in for the variable. Okay, so I'm gonna take the 6 and I'm gonna plug it in right there everywhere I see an a. So instead of a squared, I've got 6 squared minus 3 times 6, and then minus 18, and that better equal what? That better equal 0, which it does. Okay, so if you forgot to flippy flip, if you said the answer was, you know, one of the answers on the final exam is going to be negative 6 and 3. If you forgot to flippy flip, plug that in. If I plug in a negative 6 squared minus 3 times negative 6 minus 18, that should be 0. It's not 0, because so that tells you, wait a minute, I did something wrong. Okay, go back and catch your mistake. Okay, number 30, solve by factoring. Okay, but now a is not 1. Okay, so I got to do the curtain. A is not 1, so I got to do the curtain thing again. So, all right, so rainbow, 8 times negative 6 is negative 48. That's just a temporary number. What are the factors of negative 48 that add to negative 8? That's a little bit higher of a number, so if you're not good with doing those numbers right off the top of your head, use this little trick. Press y equals. I'm going to type in 48 divided by x. I'm going to second table. Okay, so I'm looking for some values here that will somehow get me to an 8. In other words, two numbers that are 8 apart from each other. There we go, 4 and 12. That will somehow get me to an 8. Okay, now they've got to multiply to give me negative 48. So one's positive, one's negative. Okay, but they got to add to be negative. All right. So is it 12 and negative 4, or is it negative 12 and positive 4? The sign of the middle number tells you the sign of the bigger one. So it's a negative 12 and a 4. So now I get to do the curtain thing. I'm going to take 8x squared. I've got to split the negative 8 into negative 12 and 4. I'm going to choose to match up the 4 with the 8. It doesn't really matter. I'll put the 4x with the 8. I'll put the negative 12x. I'll match that up with the 6. That just seems a little bit more logical to me. Okay, so all I've done, I still got the 8x and the negative 6, 8x and the negative 6. I've taken negative $8 and I've split that into negative $12 and $4. That's still negative $8. But now I can draw my curtain and I can factor by grouping. The GCF here is a 4x. And then if I divide each of those by 4x, 8x squared divided by 4x is 2x. You got to remember, subtract your exponents. 2 minus this understood 1. 2 minus 1 is a 1. 4x divided by 4x is just 1. Now here, this is what I was saying a few minutes ago, guys. Whatever number, whatever sign is in front of that first term, you got to pull that with it. Okay, so the GCF here is a 6. 6 goes into both, but that's a negative, so I must pull out a negative 6. When I divide negative 6 divided by negative 12x divided by negative 6, negative over negative is a positive, that leaves me with a 2x. Negative 6 over negative 6 is a positive 1. And notice they now match. If you had not pulled out a negative 6, then this would be negative 2x minus 1. And they don't match, and that screws everything up, okay? So make sure you pull out that negative. So now my two factors are the matching sets of parentheses, 2x minus 1, that's one of my factors, and the leftover stuff on the outside, 4x minus 6. But now we can't stop here, guys. I got to set this equal to 0, and now I got to solve. I can't just flippy flip like I did up here because the coefficients are not 1. So I actually have to set both of these expressions independently, set them equal to 0. So I'll do the 2x plus 1 first. Move the negative 1 to the other side. 2x equals negative 1 divided by 2. So one of my answers is negative 1/2. And now I've got to do the same thing with the 4x minus 6. I'll do that up here. 4x minus 6, set that equal to 0. Add 6. 4x equals 6 divided by 4. And we actually get x is equal to 1/2. Yeah, 3/2 or 1/2. however 1.5, however you want to do that. 1.5 or 3/2. Either one's fine. Okay, number 31, quadratic formula. You want to play on the piano? Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Yes, you got the song memorized in your head, but I will give you the quadratic formula on the test so you don't have to sweat it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, remember, I strongly encourage you guys to come out here to the side and label your a and your b and your c. That's my a, 3. That's a negative 1. That's an understood 1 right there. So don't get tripped up there. That's a negative 1. And my c is also, or my c is negative 3. Okay, so now it's just plug and chug. Everywhere you see a b, type in a negative 1. Every time you see an a, plug in a 3. So I have negative b, but my b is already negative. Okay, so it's negative, negative 1. And yes, that will make that a positive. Plus or minus the square root of b squared, so it's negative 1. You got to put that in parentheses, okay? Because if you don't do that, if you just say negative 1 squared, your calculator spits out negative 1 because it's doing the order of operations first. Please excuse my dear Aunt Sally. It's doing the exponents first, and then it's making it negative. But if I put that in parentheses, then it's what it's supposed to be. Negative 1 times negative 1 is 1. Don't make that mistake. Okay, b squared, negative 1, minus 4 times a, which is 3, times c, which is negative 3. And then all of that is over 2 times a, 2 times 3. Okay, I'm not going to go through, well, okay, maybe I should. Negative and a negative is a positive, so I got 1 plus or minus. All of this, guys, you can just type in your calculator, everything under the square root symbol, this whole thing. But you got to make sure you put stuff in parentheses. Parentheses negative 1 squared minus 4 times 3 times negative 3, and that gives me 37. Okay, so 37 goes under the radical, all over 2 times 3, which is 6. And that's your answer. Okay. On the final exam, it might look like this. It might look like 1 plus the square root of 37 over 6 and 1 minus the square root of 37 over 6, but that's the same thing as saying 1 plus or minus the square root of 37 all over 6. Okay, number 32. How many solutions does the following quadratic function have? You can find by solving, graphing, or using the discriminant shortcut. Okay, the easiest way to do it is the discriminant shortcut. And what is the discriminant? The discriminant is just that part of the quadratic formula. You're only looking at, and you're not even looking at the square root symbol. You're just looking at b squared minus 4ac. That's it. Okay, my a is negative 4, so that's negative 4 times negative 4. My b, oh, check that, sorry. That's why it's good to come out here and label a is negative 4, b is 6, c is 5. Okay, so b is 6, so it's 6 squared minus 6 squared minus 4. So let's write it out this way. 6 squared minus 4 times a, which is negative 4, times c, which is 5. Okay, and I just want to see what that number is. 6, sure y'all can see this. 6 squared minus 4 times negative 4 times 5. That's 116. So, okay, so if that number is positive, guys, I know that my graph is going to cross the x-axis in 2 different spots. I know I'm going to have 2 solutions. Okay, if the discriminant is 0, if you type in b squared minus 4ac and get 0, I'm only going to have 1 solution. 1. If I type all this in, b squared minus 4ac, and get a negative, you cannot take the square root of a negative number, and that's where you get the imaginary numbers. We don't have any real solutions. There's no spot where the graph crosses the x-axis. Okay, so to me, just plugging in b squared minus 4ac is the best way to answer this question on the final, guys. Now, you can do it by graphing or solving. If I graph it, then I'm just going to go to y equals. Yeah, I mean, this is a good, easy way to do it too. Negative 4x squared plus 6x plus 5. And let's press the graph button and see what it looks like. Okay, So that's actually, maybe I should take that back. Maybe the graphical way is probably the easiest way to do it. I can do the discriminant very quickly too, but I just want to see how many times does it touch the x-axis? It touches it twice. So you got two real solutions. Okay. If the quadratic comes down and only touches the x-axis at one spot, you got one solution. And if your quadratic looks like this, if it never touches the x-axis, then again you don't have any real solutions. Okay, I'm going to stop there. I'm not even going to do the solving part because that just takes too long. I mean, you just either need to do the discriminant or just graph it and see where it crosses the x-axis. It's either going to be 0, 1, or 2 solutions. Okay, 13, use the graph below for all the quadratic attributes. Okay, vertex. Vertex is the turning point, the low or high spot of the graph. That's the vertex. The coordinates of that spot are right 1, down 1. So that's 1, negative 1. The roots, okay, the roots, again, x-intercepts, roots, solutions, answers, they all mean the same thing, okay? The spot where the graph touches the x-axis, these two spots, those are the roots, okay? So you could either say 0, and I'm looking at the x values. That's a 0 on the x-axis. So you can either use 0 and 2 as roots, or if you want to write them as coordinate points, you can technically write them as 0, 0, the origin, and 2, 0. Okay, but 0 and 2 are fine as well. Axis of symmetry, that's the imaginary line that goes right down through the middle, right through the vertex. It is a vertical line, so if you can't remember how the equation goes, vertical or horizontal line, just think what axis does it cross. This is a vertical line that crosses the x-axis, so my axis of symmetry is going to start with x equals. And now where does it actually cross the x-axis? It crosses at that spot, so it's x equals 1. Also notice that the axis of symmetry is always going to be x equals the x coordinate of the vertex because it has to pass through the vertex. So I just look at that number, x equals 1. Max or min, this is a min because my roller coaster drops down, hits a minimum, and then it comes back up. So that's a min. If it were upside down, of course, that would be a max. Domain is always negative infinity to infinity, guys, always for quadratics. I always have x values along the x-axis here because this thing's going to go on forever and ever and ever and ever, regardless if it opens up or opens down. Range, okay, this is the one that students have the hardest time with. Range. Mr. Miyagi, Karate Kid, paint a fence. Paint a fence, up and down, paint a fence. This is the only one where I'm only looking at the y values. I'm going to start down here, way down here at negative infinity. I'm going to start way down here at negative infinity, and I'm going to sweep. Paint a fence. I'm going to sweep from bottom to top. Do I have any y values down here at negative infinity? Do I have anything in this area? No, I don't have anything. Okay, so I don't have any y values until I sweep up, until I hit that spot. And once again, I'm not looking at the x value, guys. I'm only looking at the y values. The range is the only one where I'm looking at these numbers. Everything else, I'm looking at the x values. Okay. So my range goes from negative 1, and I will continue as I sweep up. I will continue to have y values. Yes, 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 yes. This thing goes on forever. I will continue to have y values until I hit a y of infinity, because this thing goes on forever. Now, if it were an upside down graph, something like this, say I had something like this, and this is right at negative 2. Then, when I sweep from bottom to top, yes, I do have y values down here. So that range would be negative infinity all the way up until I sweep until I hit that spot, which is a y value of negative 2. So that range would be negative infinity to actually negative 2. Okay, but since this graph is a minimum and it opens up, my range is going to go from the vertex, okay, the y coordinate of the vertex, all the way to infinity. In behaviors, all you got to remember, guys, is where are both arrows pointing? Are they going up or are they going down? Both of my arrows are pointing up, so both of my end behaviors are going up. So as x approaches negative infinity, where are my y's going? They're going up, going to infinity. As x approaches positive infinity, where are my y's going? They're still going up. It's either going to both be positive infinity or they're both are going to be negative infinity. Okay. Oh my goodness gracious. Lord have mercy. Help us on number 34. Guys, this is the hardest problem on the whole packet. By far the hardest problem on the final exam. How do I go from standard to vertex form? Okay, you got to remember vertex form is y equals a times x minus h squared plus k. I'm in this wacky form where I got this parentheses, this binomial. This is standard form. I don't have any parentheses. This is vertex form. I have parentheses. I want to go from him to him. How do I do that? You must complete the square. Yes. Yes, you got to do it. Okay. I'm here to tell you guys, if you can complete the square on a quadratic equation, companies want to hire you. I worked for one for 10 years, so I'm here to tell you this is hard stuff. And if you're willing to show somebody that you can do this and master this, companies want to hire you. That's just not any more complicated than that. Okay, remember when I complete the square, the a value has got to be 1. Is it 1? Oh, man, they were mean to us. It wasn't 1. I'll give you a hint. The 1 on the final exam is not 1 either. Okay, so you must factor this out. Okay, so I'm going to pull out a 2, but here's the hard part. I'm only factoring out the 2 from the first 2 terms. That's the hard part. Okay, only this, because I'm going to have a plus blank in here, and the -4 is way out to the side. Okay, so if I divide 2x by 2, that's going to leave me with x squared. If I divide 12x by 2, that's going to leave me a plus 6x. Okay, so that's not that hard, but it's just going to be hard to remember to actually factor out the 2. And now I've got the plus blank. Okay, and remember, completing the square, you've always got a blank. All right, so I'm going to put a parentheses around that, and then the -4 goes out here. He doesn't get to play. And then I'm going to have another blank. And I'm not going to put plus blank because I don't know if my blank is going to be plus or minus. Okay, when I was completing the square to solve a quadratic equation, it was always a plus blank on the left and a plus blank on the right. But when I go from standard to vertex form, notice both of my blanks on the same side of the equal sign. They're both on the right hand side. So this guy is always going to be a plus blank because you take half of b squared, but this guy might not necessarily be a plus blank. So let's take a look. How do I complete the square after I factor this bad boy out? Half of b squared, half of b squared, half of b squared. That's how you complete the square. I'm going to take half of my middle term. That's my b. This is my a. That's my b. Half of 6, last time I checked, is 3. 3 squared is 9. Let me do this in red, or green. Let's go green. So I'm going to put a 9 in that blank. I have magically pulled a 9 out of thin air. And I've thrown it into that equation. You can't do that in math. I can't pull a number out of nowhere and just throw it in there because I've messed up the whole equation. So to compensate for that, to take that into account, I've got to come over here and offset that. Now here's the really hard part. Normally we say, okay, that's a plus 9, so I'd offset that with a -9. Okay, that's not the case here. I didn't pull a 9 out of nowhere. I pulled a 2 times 9 out of nowhere. Okay, 2 times 9 is 18. So I have magically pulled an 18 out of thin air. I pulled it out of the cloud. 2 times 9 is 18. So I have to offset that with a -18. I've got to keep my seesaw balanced. Okay, if I just put an 18 over here, my equation's out of balance. I've got to put a -18 over here to keep my equation balanced. Okay, that's hard. Let me recap that. Factor out the 2 only from these first 2 terms. Leave yourself a blank. What goes in that blank is half of this guy. Half of 6 is 3. 3 squared is 9. Half of b squared. 9 goes in that blank. 2 times 9 is 18. I have to offset that with a -18 to keep my equation balanced. Okay, so now why do we do all that? The reason we did all that is so now I have created a perfect square trinomial. 2x squared plus 12x is not a perfect square trinomial. I can't multiply anything by itself and get 2x squared plus 12x. But I can factor this guy. X squared plus 6x plus 9. That's one of our special case perfect square trinomials. But the shortcut that I taught you guys was, even if you don't remember the rules, you just take half of this number. Just like you took half of b to get the blank. Just take half of this number to see how it factors. Half of 6 is 3. Okay, so this is going to factor. I can't forget this guy out front. This is going to factor as, take half of that number, 3. It's just going to factor as x plus 3 squared. So half of this number is 3. I throw a parenthesis squared around it, and I bring down the sign. If this were a -6, then that would be a -3. But since this is positive, that's a positive. Okay, and then over here, I just combine my like terms. -4 minus 18 is a -22. Whew. I know, guys. That's a lot. That's a lot. Rewind the video. Watch it 2, 3, 12 times if you need to. Here's the kicker, guys. We can check with our calculator. Check it. Let's plug in this expression. Let's plug in our original expression, okay? I'm not going to type in y equals. I just want a number. Let's type in 2x squared plus 12x minus 4. Okay, 316. Fine, whatever. I don't care what that number is. Now let's type in what we think that is equivalent to. Again, I'm just going to type in this part. 2 parentheses x plus 3 squared minus 22. What do you know? Bam. That's a guaranteed lottery ticket. Take those few extra seconds and check, guys. Even if your brain drops out, and you have no idea how to solve it, you can't remember, you can still use this trick. Okay. All right, let's move on. Let's move on. Okay, we're almost out of quadratics land, guys. I promise. Three more problems, and we're out of quadratics land. Back to some easier stuff. Okay, this is quadratics. A batter hits a pitched ball when it is 3 feet off the ground. After it is hit, the height h in feet of the ball is modeled by this quadratic expression. How do I know I have a quadratic? Because there's a squared in there. Where t equals the time. How long will it take for the ball to hit the ground? So with these real-world word problem guys on quadratics, they're only going to ask you for one of two things. They're either going to ask you for the x-intercepts, which is ground. So you'll have this kind of situation where you got a quadratic and they ask you where it hits the ground, okay, which is what they've done here. Or they'll ask you when does it reach the maximum height, which is the vertex. Okay, now they've asked us for ground, so that's going to be this guy. I just want the x-intercept when my quadratic comes back down and hits the x-axis. Okay, so if I draw a more representative graph, a little bit better graph, it's going to look something like this. Okay, we're actually starting here at a height of 3. Okay, I'm starting 3 feet off the ground. My baseball goes up, it reaches a maximum height, which they don't ask for here. They don't ask us how high does it go. And then it's going to come back down and it's going to hit the ground. Okay, so that guy right there is my x-intercept. Okay, now there's two ways to do this. You can solve this quadratic manually. You can set it equal to 0 and solve. That's one way to do it, but I think the easiest way to do it is to do it the way I taught you guys in class, which is to use our trusty calculator with Mr. Spidey. So I'm simply going to go y equals, let's clear that, and I'm going to type in this expression. And instead of t's, I'm not going to use a t, I'm going to use an x because your calculator doesn't understand t's. So I'm going to go negative 10x squared. I want y'all to do this with me, type it in with me, plus 70x plus 2. Okay, make sure you got that typed in. Let's just graph it just to see what it looks like first. Okay, so I can see the graph. So it's starting here. It goes off the screen, guys, because I'm going plus 70. That baseball's going way up in the air. My graph is only right now. The scale is defaulting to 10. Well, it goes a lot higher than 10. It's going to go way up here, reach the maximum height, and come way down here. But that's the spot, guys, where it hits the ground. So I'm going to use Mr. Spidey. If you can't remember the steps, here's how it goes. You're going to press second calc. A lot of stuff with quadratics, I want calc. So second calc. And now I want the x-intercept. Do you see x-intercept in this menu? No. What's another word for x-intercept? X-intercept, roots, answers, solutions, zeros. That's another word for x-intercept. So I'm going to select 0. And now we've got Mr. Spidey. Now remember, I need a left bound and a right bound. I need to move Mr. Spidey until he's to the left, which in this case, since this line almost looks straight up and down, he just needs to be above the spot. And then I need to move Mr. Spidey to below the spot for the right bound. Now when you start moving Mr. Spidey to the left, you'll notice he jumps off the screen and I can't see him anymore. So what I would do is I would just kind of look at this second point and just kind of get an idea of about where it is and just count. 1, 2, 3, 4, 5, 6, 7. So I know my x-intercept is going to be somewhere around 7. So as I start moving Mr. Spidey, I'm simply watching the x-axis as he's moving through the spider web. And once I get close to 7, I'll start to slow down. So I should see him here in just a second. Okay, there he is. Now technically, he is above the x-axis, so he's a little bit above it. So I've got my left bound, so I press enter. Now my calculator says, okay, Mr. Manise, I need you to move Mr. Spidey to the right. So I'm just going to go one click to the right, guys, just one click. Bam. I can't see him, but I know he's a little bit further on the x-axis. That's okay. I know he's below or to the right, so I'll press enter a second time. My calculator says, do you want to guess? Yes, Mr. Calculator, I want you to guess. Press enter a third time, and bam, there's my number. Okay, so the x-coordinate is 7.03, or yeah, 7.03. So it's going to hit the ground after 7.3 seconds. Okay. All right, so if you didn't catch that the first time, rewind the video, go through the steps again. Mr. Spidey is beautiful. All right, what is the vertex of the following equation? Which way does the graph open? So the vertex, we're in vertex form. How do I know that? Because I see parentheses. So we're in the form y equals a times x minus h squared plus k. Okay, so all you got to do here, guys, this is my h, and this is my k, but you got to remember, every time we've done something with the quadratics in parentheses, what have we done with the sign? We flipped it, right? And there's no exception here. So I'm going to flip this guy, so my vertex is going to be, flip the negative to a positive, it's going to be positive 8. Do I flip this guy? No, I don't, because he's not in parentheses. The reason I'm flipping is because our equation is x minus h. If it were x plus h, then yeah, I just leave it the same, but it's x minus h, so it's the opposite of whatever h is. That's why I got to flip it. The negative 3 I'll leave alone. So my vertex is 8, comma negative 3. And it says, which way does the graph open? There are two ways to do this. You can actually plug it into your graph and visually see which way, or you can just look at the a value. If the a value is positive, it's going to open up. If this a value were negative, what does a negative mean with all your transformations that you learn in coordinate algebra? That means a reflection, right? Upside down, flip. Okay, or of course you can simply just plug it in here real quick. 10 parentheses x minus 8 squared minus 3. Graph it, and I can see it opens up. Okay. All right, number 37. What are the solutions to this system of equations? You can solve this manually. I can do substitution. I can take this guy and substitute him in for y, and I'll have a quadratic that I got to solve by hand. Or you can use the trick that Mr. Manise showed you, which is to use the intersect feature. I'm going to go y equals, and I'm going to type in these two expressions. I got negative x plus 5. Drop down. I got negative x squared. Do this with me. 4x plus 1. Okay. Make sure you guys got that typed in your calculator. I want to graph it. So press graph. And there's my line. And there's my quadratic. The first one is a line because the highest exponent is a 1. This is a quadratic because the highest exponent is a 2. I want the intersect feature. We got to use that lovely calc button. Second, calc. And I want the intersection of these 2 points, so I'm going to select number 5. So press 5. And now Mr. Spidey says, which curve, Mr. Manise? Which point are you trying to find? You want to try to find that point, or are you trying to find this point? So it doesn't matter. I'll tell Mr. Calculator, let's work on this one first. I want to start there. So I'm going to press enter. Second curve, enter. Yes, yes, enter. You're just going to move Mr. Spidey to the spot and press enter 3 times. So the intersection is 1, 4. That's one of my answers. 1, 4. Let's go back and let's do it again. Second, calc, intersection. Now I need Mr. Spidey on the second intersection. That's good right there. That's close enough. Press enter 1, 2, 3 times. There's my other intersection, 4, 1. Isn't that a lot easier, guys, than setting these two equal to each other and then solving the quadratic by hand? So much easier. Whew. Take a deep breath. We have just exited the land of quadratics. The land of quadratics. Ooh, let's go to some easy stuff. Volume. Find the volume of the cone. This is not the slant height. I know it looks like it might be the slant height, but that's not. That's just the normal height. You will have the volume formulas on the test. I'll give those to you. So the volume of a cone is 1/3 pi r squared h. And remember, anything that goes up to a tip, like a pyramid, a cone, has got a 1/3 in the formula. Okay. Do I have the radius? Got to pay attention to radius versus diameter. Do I have the radius? Yes, I do. So I just plug and chug. 1/3 times pi times 3 squared. Don't forget to square it. Times the height, which is 7. Let's plug that in. 1 divided by 3 times second pi times 3 squared times 7. And we get, I'm around that 66. 7. 66 meters cubed. All right, that's pretty easy. Volume. Volume of a sphere is 4/3 pi r cubed. This is the only one that has a cube in it. The cone and the cylinder have radius squared. This has got the cube. Do I have the radius? Nope. I got to divide by 2. Radius is 9. So 4/3 times pi times 9 raised to the third. That looks like this. 4 divided by 3 times second pi times 9 raised to the third. 3,054. And that's also going to be meters cubed. Everything with the volume is in cubic units, 3 dimensions. Okay, so now we've got a cylinder and a box, also called a prism, which has a larger volume. So I'm going to have to calculate the volume twice. Volume of a cylinder is just pi r squared h. The base of a cylinder is a circle. So the area of a circle is pi r squared, that's 2-dimensional. And then we're going to multiply by the third dimension, the height. That's how we get volume. Do I have the radius? Yes, I do. Pi times 4 squared times 10. And that is going to be equal to 4 squared times 10. I get 503. 503 centimeters cubed. The box is the hardest thing you've ever done in your life. Rectangular prism, length times width times height. 16 times 9 times 4. 576. And we have a winner. We have a winner, guys. Prism is the winner. Prism has the larger volume, 576 over 503. Okay. Oh man, oh guys, we are close. We are so close. Hang in there, hang in there. Okay, this problem is one that I created. This is very near and dear to my heart. You guys know I'm huge on the real world application. I'm telling you, I can't imagine going through engineering without having to do something like this. And I mean, lawyers, accountants, anybody's, doctors. My wife's a nurse. She looks at charts like this. So what is the trend doing? All right, so it says, based on the graph below, this is chapter 1 stuff, making a conjecture, prediction about what's going to happen next. Based on the graph below, how many iPads are being sold every month at Best Buy on average? And what conjecture, that means prediction, what prediction can you make about the number of iPads that are going to be sold probably in August? And what about September? Okay, now a couple of different ways to do this. I'll tell you the easiest way I would do it. You can just kind of go month by month and say, okay, we went from about 31 up to about 43. You can kind of break this down into each individual. You could break it down into sections of 2 months. We went from 31 up to about 48. That's about 20 per 2 months. And then I went from about 48 up to 70. That's also about 20 per month. But the way I'll do it, guys, is just find the range. That's the easiest thing to do. Look at the highest spot and the lowest spot and just subtract the two. This is right at 90. Looks like it's exactly 90. So I'm going to say 90 minus, that's a little bit higher than 30. I'll say 31. 90 minus 31 is 59. Okay, I'm just going to say that's about 60. That's approximately 60. So over the course from January to July, we've gone from about 30 to about 90. That's 60 iPads sold over the course of how many months? 1, 2, 3, 4, 5, 6. So we've sold 60 iPads in 6 months. 60 divided by 6, that's approximately 10 iPads per month for every month. So, okay, all right, I get a good feeling of what's going on here in the chart. So if you ask me, if Boss Man asked me, Mr. Maniz, how many iPads do you predict we're going to sell in August? I'm going to say, Boss Man, we sell about 10 a month. So in August, we should be up to about 100 iPads sold, okay? So August, we should be at about 110 on the sales. Okay, what about September? So I would expect this to go up to about 100. And then in September, I would expect this to go up another 10. September, I would anticipate that we will have sold 120 iPads. Okay. Oh, wait a minute. Sorry, I got these backwards. Sorry. Look at the wrong numbers. All right, so this is 90. So 10 more I would expect in August. I would expect this to sell 100. And in September, I would expect us to sell 10 more, 110. Okay, so very, very important concept there. All right, so 42, this is mid-segment. This is all Chapter 4 stuff. So this should be fresh in your minds because you just took a test on this yesterday. So, how do I know it's a mid-segment? Because I got ticks here, I got ticks here. At the halfway spot in between both of these sides of the triangle. So mid-segment is 4x minus 2. That's this guy, DF. And then AC, the base is 20. So you got to remember the mid-segment is half of the base. Well, when I have algebra, I have to actually do something. This guy is half of this. It takes 2 of these guys to equal 1 of these guys. So I need to double this mid-segment expression. I'm going to double it. 2 times 4x minus 2. And that's going to be equal to the base. To use the distributive property, 8x minus 4 equals 20. Add 4, 8x equals 24. So x is equal to 3. Okay, don't stop there, guys. Don't stop. Plug it back in. Plug it back in. 4 times 3 is 12. 12 minus 2 is 10. Is 10 half of 20? Uh-huh. Yes, it is. Because a lot of students make the mistake of setting these two equal to each other. Okay, like they do on the angle bisector theorem or perpendicular bisector theorem. And if you set these equal to each other and solve, I would add 2 to both sides. That'd be 22. 22 divided by 4 is 5.5. Okay, and when I plug that back in, this is not going to be half of that. All right, so plug them back in to check. Angle bisector theorem. This is the Spider-Man theorem, spiderweb. It says any spot on the angle bisector is equidistant. It looks like a spider web. I don't know, I just like drawing this. Okay, any spot on this angle bisector in the spider web is going to be equidistant from the sides of the angles. So that means this distance is going to be the same as that distance. So I'm simply going to set these two expressions equal to each other and solve. 2x minus 3 equals 1 at 3. 2x equals 4 divided by 2. X equals 2. Okay, now is that what they asked, guys? Pay attention. You know one of the answers on the exam is going to be 2. That's not right. They asked you to find the length of AB. Please don't miss problems because you don't read. Okay, that's a big. Honestly, quite honestly, that's a big problem with sophomores in geometry. They just don't read. You know, you got to make sure you understand what the question is asking you, because when you're 25 years old, you're going to have to make sure you understand what your boss is asking you. Okay. So that's why you're learning these important skills. I got to take this guy and plug him in where? It doesn't matter because they're both the same. 3 times 2 is 6. 6 plus 1 is 7. So the length is 7. Let's take another 3 seconds. Plug it into the other one. 5 times 2 is 10. 10 minus 3 is also 7. Okay, so check your answer. Check, check, check. Check, check, check. Last 2 pages, guys. We can do it. We can do it. Teacher, look at that. I'm here at 7:30 at night. Teacher dedication for you guys. I expect to be paid. I take credit cards, money orders, checks, cold, hard cash. Teacher dedication. All right. What do you call BF, this guy here? BFF, best friend? I don't think it's called best friend. All right, I'm looking for ticks and boxes. Okay, BF has got a box, so it's perpendicular, and I have the ticks. When I have boxes and ticks, that is the perpendicular bisector. Okay, perpendicular, box and ticks. AE, this guy here. I don't have boxes or ticks. All I have are arcs. Okay, so I know that's easy. That's the angle bisector because I'm splitting that angle in half. Okay, DH, boxes and ticks. Ticks, boxes, what do I have? All I have are ticks. I don't have a box, so it can't be perpendicular. It looks like it's perpendicular, but guess what you need to do with your eyeballs? Throw them in the trash can. That's right. All I have are ticks. So all I can say is that that's a median. I'm going from the vertex to the midpoint of the opposite side. Okay. CG, what is CG? That's this guy right here. And I see a box. All I see is a box. So that's an altitude. Okay, remember, the perpendicular bisector is the combination of the median and the altitude. Median is just ticks. Altitude is just box. Perpendicular bisector is box and ticks. Angle bisector is just arcs. Okay, more chapter 4 stuff. This is the, for those of you, if you're watching this video and you're not my student, then you might kind of hesitate here. I'll use a silly little analogy of winner and loser. The longer side is the winner. The biggest angle is the winner. So in order for me to put these in order, I have to have all three angles, which I don't. I'm missing this angle. So I need to do 180 minus 44 minus 46, and that's 90, triangle sum theorem. So this guy's a box. That's 90 degrees. So now I label my shortest side, or my shortest angle, the loser. 44 is the lowest number, so he's the loser. That means the side opposite him, this guy, is also the loser. Okay. What's my biggest angle? 90. That's my winner. So his opposite side, QS, is going to be the winner. Winner, loser. Take the L. Okay, so now when I put the sides in order from shortest to longest, that's going to be loser, shortest side first. So the loser is RS. Okay, then the medium side is the one that we didn't even label. That's going to be the QR. And then the longest side is the winner, QS. And that's all you got to do, boys and girls, winner and loser. 46, determine whether the following three lengths can be the sides of a triangle. We'll take these one at a time. And all the trick here, if you remember the trick I taught you, all you got to do is add up the two smaller numbers and see if that's greater than the third side. You don't have to do all three combinations. Just look at the two smaller sides. Look at 5 and 7. Is 5 plus 7, is that greater than 10? Yes, it is. So yes, that can be a triangle. Yes. Look at the two smaller sides, 12 and 13. Is 12 plus 13, is that greater than 25? No, it's not. It's equal to 25. And remember, I can't have two lengths that are equal to each other, because if I have that, I can't make a triangle. I just got two lengths laying on top of each other. It's just a straight line. I can't make a triangle with that. It has to be greater than, not equal to. 3 plus 4, is that greater than 6? Last time I checked. And is 30 plus 42, is that greater than 70? 72 is not greater than 70. So that's a big fat no. Okay, two sides of a triangle have lengths of 11 and 16. Write an inequality for the possible range of values. So when you see this word, guys, from the chapter 4 stuff, range, you're going to have an inequality. You're going to have two inequalities. You're going to have x sit in the middle of two numbers. Okay, and if you remember the little trick, all you got to do is add the two numbers to get the high end and subtract the two numbers to get the low end. 11 plus 16 is 27. 16 minus 11 is 5. Okay, so x has to be less than 27, and x has got to be greater than 5. Because think about it, if x were 4, okay, 4 plus 11, that's not greater than 16, so that doesn't work. If x were greater than 27 or x were 30, 11 plus 16 is 27, that's not greater than 30. So that's why we get these two parameters, these two constraints. Okay, add the two numbers, subtract the two numbers. 2 problems. I'm in 1 hour and 38 minutes. We're going to be under 2 hours for this thing. All right, find the range of possible values for x. This is the hinge theorem where you have two different triangles. Okay, so this was section 4.61 triangle. This is inequality with two triangles, hinge theorem. I'm still going to use my winner and loser analogy. 23 is the winner because he's longer than 22, so poor 22 is the loser. That means the angle opposite from the winner is going to be the winning angle. So the 75 is the winner, which means this poor expression, x minus 13, he's the loser. Okay, now, it's an inequality. I've got a range of possible values. So this is a little tricky. You got to set up two different inequalities. Since 75 is the winner, he's the bigger angle. So that means this expression, whatever it is, cannot be bigger than 75 because x minus 13 is the loser. So x minus 13 has got to be less than the winner. It's got to be less than 75. This is quite easy to solve. So x has got to be less than 88. Okay, that's one constraint. And then in the hard part, what does this expression have to be above? Okay, it's got to be above 0. X minus 13 has got to be greater than 0 because I cannot have a negative angle. Think about it. If I were to plug in something less than 13, if I were to plug in 10, 10 minus 13 would be negative 3. I can't have a negative 3-degree angle. So x has got to be greater than 13. Okay, anything less than 13 gives me a negative angle. So I got to combine these two constraints and say throw x in the middle. It's got to be less than 88, and it's got to be more than 13. Now, if you're one of those students that can't remember, I'll show you a little quick trick. If you can't remember the difference between the greater than and less than sign, some of you guys were taught the alligator. I'll provide you with an alternative way to think about this. 10 is greater than 7. 2 dots is more than 1 dot. Okay, so that tells you which way the inequality sign opens. 2 dots is always going to be with the bigger number. Okay, just another way to think about it. And the last one, inequality that relates side AB and BC. So once again, this is the hinge theorem. They've given me this angle 100 degrees, and I need this angle. I can't say anything about these two sides unless I know who's the winner and the loser. So I got to do 180 minus 100, which is, of course, is 80. So this angle is 80 degrees, and now I can do the winner and loser. The 100 is the winner. The 80 is the loser. So the 80's opposite side, AB, is going to be the loser. The winner, the opposite side, the CB, that's going to be the winning side. So that means CB, or BC, doesn't matter the order, it's got to be greater than the loser, AB. Or you could rearrange this and you could say AB is less than BC. Of course, either of those inequalities works. 2 dots is more than 1 dot. 2 dots is more than 1 dot. Okay, longest video I've ever created in my entire life. 1 hour and 41 minutes, guys. I hope you enjoyed this. I hope you got some confidence. Go back and watch this video. Man, if it takes you 3 hours to watch it, spend 6 hours. If you're one of those few students who are on the borderline for passing and failing this class, watch this thing 2, 3, 4 times. Tell yourself, I'm willing to put in 4, 5, 6 hours to make sure I get the grade that I want. Okay, this is important. This is 20% of your grade. So don't take that lightly. So I hope you guys enjoyed this video. I wish you the best of luck. Please come in for tutoring. Please see me one-on-one. Let me work with you. Anything that you still don't understand from the video, we'll hash it out one-on-one. Check these posted solutions on my website because I've written out everything. I went through some of these, maybe a little bit fast because I knew it was going to be a long video, but I've got the hard answer key posted on my website, and it looks like this. Here's the posted solution where I actually write out stuff. I go through and kind of write out everything that you need to know, all the little hints and reminders. Okay, so check your answers online as well. All right, this is Mr. Manise signing off after a 1 hour and 42 minute video, and we will see you on the next one. Good luck on the exam.